ये एमडी की क्लास है।
गुड इवनिंग सर। फारूकी साहब नमस्कार, गुड इवनिंग।
Good evening.
Very good evening, sir.
Good evening, sir.
Good
evening, sir.
Good evening, everyone. So, how are you all? So let us start.
Yes.
Sure, sir.
Yes, sir.
So today,
Can we record this session, Jamal sir, so that in case anybody later on wants to hear? Thank you.
Recording in progress.
so we have two groups joining this class. One is the senior people who are enrolled under IMA PhD program, and the second one is our regular MBA students also, because what I thought that for the same topic, let me ask them to join this class as well. So this is how we will be having these two groups. And for the IMA group, I would like to tell that we have, this is in continuation of what we have done earlier. There are four broad topics, you can say, the four modules under section A, and four or three modules under section B. So section B of this course was engaged by Dr. Asif Akhtar, where is there any class left for Asif also?
Yes, sir. One more on coming Tuesday.
Okay. And for part A, we already had covered two modules, and now the third one and the fourth one we need to cover in these sessions today and tomorrow. So this way, this course, this syllabus will be complete. For MBA students, I would like to say that this is from another unit. One first unit of your course has already been done by Dr. Asif Akhtar, and now we'll be taking this probability part today. So you please be careful that the portion, the topic that I will be covering today are related to your fresh unit, which is on statistics. So let me share my slides now.
Kiran ma'am, if you can mute all others other than the professor.
Is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir. Visible.
Yes, sir, it is.
Probability is a very important dimension of statistics, and as we all know that while making decisions in business scenario, since the decisions are made for future, and as we know the future is not certain, so what do we do that with the help of the present information and the past experience, we can somehow make estimate of what is possible in future, and that step, the estimation of what is probable in future, is basically done through probability calculation. So in that sense, knowing the concepts and application of probability is important for management students. When I say management students, I don't mean that IMA group is that type of student. They are not fresher, we know. But I mean, application of probability is always there because you are all working people. And this is a time, as we have discussed earlier also, for IMA group, that you may not necessarily be doing it for the first time, but at least you can brush up your knowledge, and also you need to clear this paper under your foundation program. So let us first understand probability may be defined as a numerical measure of any likelihood that a particular event or outcome, we will understand what is event and what is outcome, will occur when an idealized experiment is performed. So this is from examination point of view, that if you need to write this or to understand probability, there are three important words which you can underline. One is, it is a numerical measure, means probability is represented in numbers. Which number, which form? It is in percentage form, or it is a number simply from 0 to 1, which represents likelihood of a particular event or outcome. We will understand further when an idealized experiment is performed. So with these three important words in this heading, we will switch over to the next one. So this was okay. For example, as we say, there is 90% chance that a particular project will be completed in 30 days. We will now these days be talking about looking at the exit poll. What is the probability that which party will win or which candidate will win in a particular election, as the elections are going on these days. So that is probability. 90% chance that the project will be completed in 30 days. Now we come to these definitions, which the word that we were using while defining probability. Idealized experiment in the context of statistics or probability is that some activity, some task which is to be performed. This is not necessarily an experiment which is done in laboratory. So this is here in statistics, this experiment means any activity, and by idealize we mean that the outcome of which are known to us. For example, when we toss a coin, so tossing a coin is an experiment, and if the coin is fair means it has one side as tail, the other side as head, and there is and it cannot stand when we toss it, it will not stand on its edge, then it is called an idealized experiment, and the coin is a fair coin. Sometimes while solving numerical examples on this, because tossing a coin is a very common and simple example to explain various terms under probability. So fair coin in this case is the coin which has two sides, one head, one tail, and when you toss it, it does not stand on its edge. And by idealized experiment here we mean tossing a fair coin with two known outcomes, head and tail, there is no third probability. So that is what we mean by idealized experiment. We generally use event or outcome interchangeably for the results of this experiment. When we toss a coin, so the outcome is either head or tail. But many times in different situations, we need to describe a combination of certain events, certain outcomes. So in that case, event becomes a combination of different outcomes. But I mean, commonly event and outcomes are interchangeably used. By sample space, we mean this is a set you understand we have done in the first session. A set is a collection of elements, collection of some objects. Here, sample space represents a set of all possible outcomes of an idealized experiment. So if again coming to tossing a fair coin, there are two possibilities only, head and tail. Head can be represented by H and tail by T. So in that case, a sample space will be represented by a set. You know the notation for set, which is one parenthesis, and within that we write H, comma, T. So that set will represent the sample space for tossing a fair coin. By mutually exclusive events, we mean those two events A and B which cannot occur together. Again, head and tail, either head occurs or tail occurs, both will not occur together. Equally likely can also be explained with the same example that there is 50% chance of head and 50% chance of getting tail. These are two basic laws of probability. As you all know, that probability of an event is between 0 and 1. 1 means 100%, 0 means 0%. So probability cannot exceed 1 or cannot exceed 100%. So while solving numerical example, this gives you an idea if in any problem your answer is for probabilities coming negative or more than 1, then it is alarming and you should know that something wrong you have done, because probability cannot be less than 0 and greater than 1. And the second law is the sum of the probabilities for all outcomes of an experiment must be equal to 1. Again, a simple thing to understand. What are the two possible outcomes for tossing a coin? Head and tail. Probability of occurrence of head is 50% and probability of occurrence of tail is 50%. The sum is 1. So the sum of probabilities for all outcomes, there are only two possible outcomes for tossing a coin, and the sum of their probabilities is 1. These are three probability approaches. Means we either go for classical method to estimate probability, or relative frequency method, or subjective method. Let us first discuss subjective, because there is no calculation involved as such. Subjective method of estimating probability is simply a person's degree of belief that particular event or outcome will occur, and this belief is based on his or her experience, intuition and the situation. जैसे कभी मौसम को देख के हम लोग कहते हैं कि थोड़ा विंडी है, थोड़ा क्लाउडी है, so we can say, and we know that say in February sometimes it rains, so we can say there is a 30% chance that it may rain. So that 30% chance, looking at the atmosphere, that it's windy, it's cloudy, and then we have experienced that sometimes it rains in the month to February. So on that basis, you can say there is a 30%, 40% chance that it may rain. It is subjective method. And as we have discussed in the beginning that for decision makers, we have two approaches. One is quantitative approach, the other one is qualitative approach. And we have discussed that for qualitative approach, all these things, experience, intuition, and past knowledge, etc., they are all important. So subjective, this is subjective method of estimating probability of something with past experience, with some intuition, looking at the present situation, and then we can associate probability with certain event. Relative frequency method is used, say, when we want to calculate in an IPL tournament, if for example,
Sir, we lost you there.
hello?
No, we can hear you. Ranjit, we can hear you, sir.
You can hear me as well as the slide is also visible?
Yes, sir.
Yes, sir. All working, all fine, sir.
Okay. So relative frequency method, if say for a cricket tournament, India is playing with a particular country, and you know that number of occurrences of A, and A is the India winning. A is denoted by A represents India winning. So the probability that India will win this particular match is the number of times India has won divided by number of matches that India has played. So that is what I mean by relative frequency method. So probability of A, here A denotes the chances, or probability of A means probability that India will win a particular match can be calculated if we know the number of times India has won divided by number of matches India has played. And by classical method, we mean A plus B. If we can estimate somehow the chances that okay, this will I will explain when we switch over to some numerical example, because otherwise you will be confused between classical and relative frequency method. Any question from this slide?
No, sir.
Now, my advice is that the classical method, this you can write down, because when we move to another slide solving some example, it will be with you. So you can write down this classical method like this, and relative frequency is easy. I mean, so this also you can note down before we move further. Done?
Done,
Yeah.
sir.
Yes, sir.
Okay. Then we come to these basic relationships. This also you should note down. We will be using this while solving numerical example. Probability of A plus probability of A complement. This is A complement. The sum is 1. And A complement is what? Anything which is not A.
The remaining part.
Yeah, yes. Anything which is not A is A complement. So probability of A plus probability of A complement, the sum, because we know that sum of all probabilities of the outcomes of an experiment must be 1. So this relationship is derived from that basic rule, that the sum of all probabilities of the outcomes associated with an experiment should be 1. Then second is, we read it like this: probability of A union B. A and B are two events. So probability, if you want to calculate probability of something where either A occurs or B occurs, and we can read it like this: probability of occurrence of A or B. We can also understand it like this: probability of either A occurs or B occurs. And using symbol, we can the left hand side, A union B. This is called A union B, and it is explained as probability of either A occurs or B occurs, or we can also say it like this: probability of occurrence of A or B. And now right hand side is the sum of the two probabilities: probability of occurrence of A plus probability of occurrence of B minus probability of the third component is probability of joint occurrence of A and B. So with these symbols, you should understand that A union B is probability of either A occurs or B occurs, and the probability of A intersection B means events together. And the third expression is how to calculate this P A intersection B. It is multiplication of both probabilities. Of course, if A and B are mutually exclusive, then the third component in the second expression becomes, if A and B are two mutually exclusive events, then the third component of the second expression becomes
0, because they are
zero, because A and B are mutually exclusive. They cannot occur together. Therefore, there is no intersection. So that is the third component of the second expression. It becomes 0 if A and B are two mutually exclusive events. So before coming to next, we should note down this formula, because we need to use them while solving numerical example. Now these probabilities can also be represented graphically, means the outcomes. So one way to represent these outcomes of an experiment is using Venn diagram, which represents outcomes occurring in a single trial, means static. And a tree diagram is used to show the outcomes of a sequence of trials. जैसे अभी हमने कहा कि if you toss a coin, there are two possibilities: either you get head or tail. If you toss it again, means second trial, then again you will be having those two possible outcomes. So this way we can represent these outcomes using a tree diagram, because here we are representing the outcomes of a sequence of trials. Trial 1, trial 2 means toss 1, toss 2, and similarly toss 3, and so on. But Venn diagram, which is represented using a box and circle, that is used to show the outcomes occurring in a single trial. Say, for example, if there are three outcomes A, B, and C, and the distribution of these outcomes is like this, that A is 21%, B is 29%, C means probability of C is 38%, and also the probability of joint occurrence of A and B is 5%. Is this visible? Example 1 and then 2.
Yes, sir.
Yes, sir.
And probability of A and C is 9%. Probability that B and C occurs together is 7%. And the joint probability of occurrence of all these three is 3%. So can you try this, how to represent this information using Venn diagram?
Sure, sir.
You must have done it somewhere, all of you. Means our MBA students who are fresher, and the I'm a group also.
Yes, sir.
I hope some of you could do it, if not all.
Sir, done.
Good. Can anyone show it?
How to share?
If you're not speaking to me, please. If you are not, participants are requested to mute themselves if they are not speaking to me. Can you see this?
Yes, sir.
Yes, we can see.
Yes, sir.
So there are three circles in a rectangular block, and that rectangle which include these circles is the union or the universal, complete. Nothing will be out of this. And the probability of A is, the information is given is 21%, means 21 out of 100. The portion, the shaded portion represents, what does the shaded portion represent?
A intersection.
A, B, A
Intersection B, intersection C.
And
Common,
which is,
mutual.
how much is this? Is 3%.
Yeah.
So number here in numbers it will be 3, and similarly you can see A and B as 5. 3 plus 2, 5. 3 is the common one, the shaded one, and the 2. So A and B together 5, A and C together 9. 6 plus 3.
Yeah.
And
Yes,
B and C as 7. So it will be 3 plus 4, 7 you can see. and altogether A is 21 out of 100. How 21? 10 plus 6 plus 10 plus 6 plus 4. No, not 4. 6 plus 3 plus 2. 6 plus 3 plus 2 plus 10. So that makes 21. Am I right? For A, event A, it occurs 21 times out of 100. So you can count this 21 now. And what does this 10 represent then?
So probability of A only, excluding all the other common
Yes.
mutually
So,
exclusive events.
right. So now you can understand, you should understand that probability of A and probability of A only are two different things. From this diagram, from this information, you should understand that probability of A is 21%, 21 out of 100, which includes any association of A with either B or C or both. But if you are talking about A only, then it will be that portion which is not being shared with any other event, B or C. Is that clear?
Yes, sir.
Yes, sir.
Then any reason why you did not represent it as a 0.2? I mean,
Sorry?
in decimals. Why in
Because-
the Venn diagram you have not showed it in decimals?
Because the total number we are showing in numerical value, not as percentage. Otherwise, this 100 will be 1. If you represent, say, 0.21, so the total will be 1 then.
Yeah. Is it okay? I mean, I did it like that. Is that okay? Acceptable?
It's better to do it like this. The reason
Okay.
is that we are talking about total outcomes. So total outcomes are 100. Or say, for example, if you talk about a class where you have 100 students, out of which A belongs to a particular stream, B belongs to another stream, and C belongs to another stream. So basically, we are talking in terms of numbers in that case. So if that is the situation, we should represent them in numbers rather than in fraction or decimal.
Thank you, sir.
Okay. Now coming to the next one, represent all the possible outcomes of tossing a fair coin twice by a tree diagram. A tree diagram means when you toss a coin, there are two possibilities, and tossing a coin as such may be denoted by a node, a circle, a small dot, a bullet, whatever, and then there will be two lines branching out of this node. One will represent head, the other one will represent tail. You can see this?
Yes, sir.
Yes.
And when you toss second time, now you need you have to represent those outcomes for the second trial in the same diagram. So try to incorporate the outcomes of the second toss. And because of this shape, it is called tree diagram. It is branching out from one origin. So first trial outcomes shown by 2 branches. That is your first trial or first toss. Then second toss. Now here we have 4 branches. Whether it was head or tail, because we have not yet tossed the coin. Experiment is to be performed. So we don't know what was the result in the second, what will be the result in the second trial. So this is how we expand or we represent these outcomes in the form of branches or tree. Like this. So either head occurs or tail occurs. Then whether it will be head or tail in first trial, second trial will be again head or tail or head or tail. So as a result of these 2 tosses, what are the probable outcomes? At the end we can see what are the probable outcomes which you can read.
HT, TH.
So HH, HT, TH, or TT.
Right. So that means there are 4 possible outcomes. Now we can call this HH as an event. It is a combination of 2 outcomes. First outcome, first trial as H, and again second time H occurs. So H and H. We are writing in HH. We can read it like H and H or both H. So these means terms, the way we express them are, this is important. Sometimes it is asked as question, probability of both H, probability of having 2H, probability of having H and H. So it can be stated in different forms, but meaning the same. So you should be very clear about what is being asked and what does that mean. So 2H, HT, TH, and TT. So that means what we can say, that there are 4 possible outcomes of tossing a fair coin twice. And what is the probability of first H?
0.5.
0.5. And what is the probability of second H?
0.5.
5.
Because why it is so?
Because there are possible 2 outcomes. So one will
They
be
are, yes, they are independent in the sense that whether it was H or T in the first trial, it has no influence on the occurrence of head or tail in the second trial. So therefore that is also 0.5. So now you write down this 0.5 above all these branches, all these lines. So everywhere it is 0.5. And therefore HH, probability of HH becomes
0.25.
0.25. (0.25). PHH is 0.25. What is PHT? Is again 0.25. PTH is 0.25 and PTT is 1. And what is the sum?
1.
1.
1. Because
Probability cannot be greater than 1.
Probability should be.
no, that is okay. But it is the second rule, that sum of all probabilities
Will be equal to 1.
Should be 1.
1.
Sum of all probability should be 1.
1. And all probabilities means we are talking about the probabilities of possible outcomes of an experiment. तो यहाँ experiment जो था वो एक coin को 2 बार toss करना was an experiment here. उस experiment के जो result थे वो इस form में possible थे. when we associate probabilities with all these outcomes, we can calculate it means 0.5, 0.5, and the sum of all these probabilities must be 1. Now, we have also noted down that probability of A and B. How do we express probability of A and B? If A and B are two outcomes or two events, how do we calculate mathematically probability of A and B?
So probability of A into probability of B.
No, what do we do? Means we add
The probability like A upon total number of outcomes. Probability equal to A upon total number of outcomes.
No, hold on. What is the formula for calculating probability of A and B?
Sir, A divided by A plus B.
No.
Probability of A plus probability of B is equal to 1.
No, A intersection B. The third one that you must have written, third one. Yeah.
E in the bracket A intersection B is equal to
A and B. As we have discussed, that A intersection B is also expressed as A and B. So probability of A and B is given by the product of the two probabilities, probability of A and probability of B. अब आप अपने वापस ट्री डायग्राम पे आइए. Probability of H and H. How will you calculate? A and B की जगह अगर H and H हो, तो how will you calculate the probability? What is the probability of first H?
pH into pH, that is 0.5 into 0.5.
Right. What is the probability of first H? I'm asking.
0.5.
I'm asking to all of you.
0.25.
No, I'm asking to all of you. What is the probability of first H?
0.5.
0.25.
Again, somebody is saying 0.25. What is the probability of first H? 0.5 only.
Yes,
And
sir.
what is the probability of second H?
0.5.
Okay, so pH into pH.
0.25.
0.25.
So this is what we have done here. Probability of H and H is 0.25. Similarly, what is the probability of first H? 0.5. What is the probability of T then? It is again 0.5. So probability of HT is also
0.25.
0.25, and so on. Okay. Now coming to this classical method. Probability of A. Here A is, for example, the event of interest is having 2H. If you want to know what is the probability of having 2H, 2 heads, as a result of tossing a fair coin twice. So now right hand side is small a over A plus B. So small a in this case is number of favorable outcomes. I told you that I will explain it when we come to some numerical example. Small a is number of favorable outcomes, and small b is number of unfavorable outcomes. Favorable to what? Favorable to the left hand side, means the event of interest. What is the event of interest? To have both H. So how many outcomes of the 4 outcomes are favorable to having 2H in our case?
1.
1.
And how many are not favorable?
3.
Because HT is not 2H, TH is also not 2H, and TT is also not 2H. Out of 4, we have only one outcome which is favorable to have both heads. So therefore, probability of having 2 heads as a result of tossing a fair coin twice is small a. What is small a? 1 divided by
4.
well, 1 plus 3. So 1 by 4, and how much is it? It is 0.25.
0.25.
So that is what you have calculated. Now you understand what is classical method.
Yes,
So
sir.
with the help of this problem tree diagram, we could understand many things. How to calculate probability of two events. What does this classical method mean? What is small a? What is small a and b? And what does that sum of all probabilities is 1 mean? All these things we can now understand with the help of this probability or tree diagram. Any question?
No, sir. Clear.
No,
Okay.
sir.
So,
You proceed.
So it was same. Yeah. Now, coming to this, marginal probabilities are either marginal probability or joint probability or conditional probability. And we will understand this in terms of two events only, A and B, to make it simple. Marginal probability is simply the probability of that event we are talking about, say probability of A. Joint probability, as the name indicates, is probability of joint occurrence of A and B, two events. And conditional probability is probability of occurrence of one given that the other one has occurred. Means if you read the right hand side, we will read it like this. What is the probability of B given that A has occurred? And the symbol that we have in between A, B and A is vertical slash. It's not divided by. It's not a symbol for division. It's a vertical slash, and we read it like this: probability of B when A has occurred. So that is what we mean by conditional probability, because we will learn that in some cases, if A has occurred, the probability of occurrence of B might change. So, depending on the relationship between A and B, there are two types of statistical conditions. One is condition of statistical independence, and the other one will be condition of statistical dependence. If A and B are statistically independent, मतलब क्या हुआ कि A के occurrence से B पर कोई फर्क नहीं पड़ता और B के occurrence से A पर कोई फर्क नहीं पड़ता. जैसे अभी हमने देखा था कि एक टॉस के बाद सेकंड टॉस में whether it was H or T in first case, it has no effect on the occurrence of H or T in the second try. So probability under statistical independence condition, probability of A we can calculate simply as probability of A, and these also you should note down. We need it to solve problems. And probability of A and B, now we have simplified it. Instead of giving A intersection B or something like this, probability of AB simply is the probability A multiplied by probability of B. And the third one, right hand side is same as left hand side. How do we read left hand side? Probability of B given A has occurred. But since we are talking about statistically independent conditions, that means A and B are statistically independent. Therefore, probability of B, whether A has occurred or not, it will remain as probability of B. Okay,
Yes, correct.
so you have noted down.
Yes, sir.
And this is how these three probabilities are given when A and B are statistically dependent. Probability of A is probability of A. AB is now expression second and third. They are one and the same, just rewriting rewriting these components. इसको समझिए, सेकंड एंड थर्ड इज जस्ट रीराइटिंग. चाहे आप थर्ड से सेकंड को ड्राइव करें या सेकंड से थर्ड को ड्राइव करें.
Correct.
The third one is in simple form is also known as Bayes theorem. We will take a Bayes theorem. This is a simple form of Bayes theorem. The third one. नोट कर लिया?
Yes, sir.
Yes, sir.
Yes, sir.
Now we come to some numerical example. Please mute yourself unless so first example, which is 3 here. A is a student. Okay, A can solve 80% of the problems and B can solve 90% of the problems in statistics. There are two students. One is A, one is B, and A can solve 80% of the problems in statistics, whereas B can solve 90% of the problems. A problem is selected randomly. What is the probability that first part and the second part? Now, with the help of all the formula that you must have noted down, try to solve these problems, then we will discuss. So just focus on example 3 only for the time being. Part A and part 2. Then we will take up example 4. Any answer?
So
Sir, sir 0.98.
0.98.
Or
0.98 will be, sir, for the first one.
okay,
At least one of them.
Sir, is it 26%?
0.26.
ठीक है अभी देखते हैं.
Sir, one is 0.76 in example 4A.
जी. Okay. Let us first understand this expression. Probability that what we want to calculate is
A or B.
So at least one of them, either A is able to solve or B is able to solve.
right. So it can be written like this: probability of that the problem is solved, or it is same thing as probability that at least one can solve. Both statement, both sentences are one and the same, because A and B are solving this problem independently. So what are the three possibilities?
Either A solves it.
Yes.
So either A solves or either B solves or both of them solves.
Right. So in any case, the answer is the problem is solved. So that is why we understand how to calculate, means what is the probability that either A solves or B solves. So we can write it problem is solved, or we can say probability that at least one can solve, or we can write it like this: probability that either A solves or B solves. जाहिर है कि जो बोथ सॉल्व में प्रॉब्लम तो सॉल्व हो गई, चाहे दोनों ने कर ली, बट so what I mean to say is that the same thing can be expressed differently. Probability of at least one of them, probability that problem is solved, probability that either of the two solves it, and so on. So that is left hand side, probability of A union B, and right hand side is probability of A plus probability of B minus probability that both can solve. So probability of A is 0.8, because 80% of the problems A can solve 80% of the problems, and probability of B is 0.9, and probability of A and B you can find out from here, that is PA into PB. And what is that? How much?
0.72.
0.72.
So 72% is the chance that both A and B are solving it independently, alag alag. So what is the probability that both can solve is 72%. Both does not mean here that it is a joint effort. A and B are solving it independently. So probability of both solving is 72%, probability that A solves is 80%, and probability that B solves is 90%. So that is how your answer is 0.98 correct. The second part is exactly one of them solves. So first we will understand what does it mean, and then how can we express it in mathematical form. So exactly one of them solves means either means if A solves, B does not solve, and if B solves, A is not able to solve. ये दो situations possible है if we are interested in exactly one of them solves. The first situation may be A solves, B does not. So that means probability of A, B complement. क्योंकि अब probability of B solving is probability of B, then probability of B not solving will be how much?
0.08.
0.1.
Yes, 10%. 10%. That is B, C or B prime. Similarly, A prime or A complement is 0.2, 20%. तो अब इसमें सिचुएशन ये बनी कि लेफ्ट हैंड साइड में जब हम इसको लिखेंगे तो इसको एक्सप्रेशन ये होगा प्रोबेबिलिटी विद इन ब्रैकेट A B suffix C or A B prime or A dash or A suffix P B. Let me show like this. A that will be your left hand side. Probability A B dash or B prime or B C, or the second situation. Is this clear?
Yeah, noted.
Yes, sir.
And now the first component will be A B dash will be how much? Probability of A multiplied by probability of B C.
B complement.
B complement. So that is 0.8 into 0.1. ये पहला पार्ट हो गया. और के बाद वाला पार्ट probability of AC into B. AC is 0.2 and B is how much?
0.9.
0.9. So this is 0.18. 0.18. So 0.08 plus 0.18. Why plus? Because it is OR. We have the mathematical operator as OR. And when we have OR, we add. And what about the third component? Because probability of A or B is given as
It's
देखिए A or B is PA plus PB minus PA and B. There is third component also.
cannot happen.
What
right?
is that third component? Third component.
So A intersection B 0.72.
0.72.
No, not A intersection.
No.
Not A intersection B. Intersection of ABC and ACB. Intersection of
So 0.018.
I'm talking about this. I'm talking about this. Intersection of here.
So 0.0144.
So 0.1.
0.144.
0.018.
यही तो थर्ड कंपोनेंट होगा ना.
Yes, sir.
Can it really happen?
This encircled expression is your third component.
Yes, sir.
So what is it? What is this? How much is
Sir, 0.144.
144%.
So 0.0144.
0.14.
No, but this can't happen, right? Because the thing is exactly one of them solves. That's what the question is. So this should not be a possible outcome.
Yes. So be careful. ये सिर्फ फॉर्मूला लिखने से या याद करने से नहीं होगा. You should understand also. So in this case, the third expression is 0. It can't happen. Why? Because exactly one of them solved. That is your event of interest. तो ये दोनों एक साथ नहीं हो सकती कि A ने सॉल्व किया और B नहीं कर पाया और B ने किया और A नहीं कर पाया. ये दोनों एक साथ नहीं होगा. Is this clear?
Yes, sir.
Yes, sir.
So therefore, this third term is 0 in this case, and therefore somebody has already told the answer is 0.26, so that is correct answer.
Sir, but I, sir, did a different logic while arriving at 0.26. What I did actually, sir, what is the probability of either of them solving? That will be simply union of A and B. So that will be, according to the formula, that will be 98%. Sorry, 170%, sir. And then what I did, solving together, that means simply multiply A, probability A and probability B, that gives 72%. Now, if we subtract 72 from 98, the answer is 26%.
Take, that is also correct.
Okay, sir. So I thought that was easier actually.
But you know what is that 26%?
So,
the answer is correct.
Right, sir.
But does that represent what we are looking for?
Now I am confused, sir. Now when you have explained this.
So probability is all about confusion.
Right, sir.
So anyway, so my point here is that while solving numerical examples on probability, be careful about the expression and about what is given and what is required. इसीलिए एग्जामिनेशन के पॉइंट ऑफ व्यू से आई विल सजेस्ट यू शुड राइट ऑल स्टेप्स so that even by mistake if your answer is not correct and the examiner can see that your steps are correct, then you will not lose much. I'm talking about from mathematics, from examination point of view. और अगर इसको शॉर्टकट में करने की कोशिश करेंगे, आंसर भी गलत होगा, तो the whole exercise will be useless. So it will be up to the examiner कि उसको कैसे ट्रीट करे. तो इसलिए प्रोबेबिलिटी के सॉल्यूशन में, although it's important everywhere while solving numerical example, so step by step solution is always advisable. तो उसमें गलती होने के चांस भी कम होते हैं और एग्जामिनर के लिए भी ये उसकी प्रोबेबिलिटी भी होती है ज़्यादा कि वो इसको रिड्यूस कम करे मार्क्स को. तो बट on the other hand, this is also correct that those who have done this earlier and those who can do the same problem in different ways, तो उसमें कोई restriction नहीं है. You can solve it whatever way, क्योंकि probability में वो कुल मिला के sum 1 है या 0 है, वो बात अपनी जगह एग्जिस्ट करती है. तो आप किसी भी तरीके से कर सकते हैं, लेकिन वो तरीका आप स्टेप बाय स्टेप एक्सप्लेन करेंगे. So that 0.26 now, and here is an example. 0.26 you can obtain by what you are explaining, and 0.26 we obtain by what we have solved, because they are I mean they are one and the same thing. जिसको ये कॉन्सेप्ट क्लियर है वो उसको दूसरे तरीके से भी कर सकता है. तो इसलिए इसमें कोई रिस्ट्रिक्शन नहीं है, बट यू शुड बी करेक्ट इन योर लॉजिक एंड यू राइट इट स्टेप बाय स्टेप. So should we move to the next one?
Yes, sir.
Example 4. it's easier as compared to, I hope. A salesman is known to sell a product in 3 out of 5 attempts, while another salesman in 2 out of 5 attempts. Find the probability that no sale will take place when both try to sell the product, and B, either of the two will succeed in selling the product.
So 0.76 of A.
So A is 0.24 and B is 0.76.
So first answer is 0.24 because this is probability of, how will you express it?
So probability of A complement into probability of B complement.
Right. And second part is simply A union B. Either of the two will succeed in selling the product. Probability of A plus probability of B minus probability of A and B. So no sale will take place means 24% is the probability that no sale will take place, and second is 76% A or B or A union B, probability of A which is 3 by 5 plus probability of B which is 2 by 5 minus probability of A and B, 3 by 5 into 2 by 5. So it comes out to be 0.76, or it is simply what?
1 minus probability of
1 minus
not making
probability
a
of
Yes,
not
1 minus
occurring.
0.24. Because again the sum has to be 1. और दो ही बात हो सकती है, या तो प्रोडक्ट या तो सेल होगी या सेल नहीं होगी, और दोनों का मिला के प्रोबेबिलिटी 1 होनी है. तो एक की प्रोबेबिलिटी 0.24 है, दूसरे की प्रोबेबिलिटी 0.76. Is there anyone who has not been able to solve these problems? Is there any question,
Sir, can you please explain the A part of example 4 once again?
No sale will take place means A complement and B complement. Means probability of A complement into probability of B complement. Complement इसलिए कि उसके सेल करने की probability 3 out of 5 है, न सेल करने की probability क्या होगी? A complement. Is your question answered or not?
Yes, sir. Yes, sir. Thank you.
Now this one. A parcel delivery firm is worried about the likelihood of strikes by some of its employees. The probability of a strike by the firm's pilot is estimated as 0.75 and that by the drivers is 0.65. If the drivers strike, there is 90% chance that the pilots will strike in sympathy. So how will we understand this 90%. What does this, which situation does this represent?
The conditional probability.
Conditional probability. Individual probabilities are 65% and 75%. But if the drivers strike, there is a 90% chance that the pilots will strike it in sympathy. Means if we use some symbol to represent this 90%, so how can we write it?
PFB slash
ठीक है, लिखिए आप.
Sorry, the reverse. PF pilot, given pilot will strike, the drivers strike.
उधर हो रहा है समान.
The last expression on this page you can see. Probability of pilot striking, given that probability of probability of pilot striking, given that drivers are on strike. Am I right?
Yes, sir.
So this is how
Yes.
we can denote it in symbolic form. Probability of PS, given that drivers are on strike. So that is given as 0.90. Similarly, you can write these 0.65 and 0.75 using the same symbols, PS and DS. P is for pilot and D is for drivers, S is for strike. And then try to work out the first one, determine the probability of both groups striking, or दूसरा वाला drivers striking, given that pilots strike. Now you will use that expression of
The Bayes theorem.
Because this is statistical dependence. Second and third. So using this, try to solve this problem.
If the driver strike, there is a 90% chance driver striking, it will strike.
Zero 0.585, sir, first one.
Yes, sir. 0.585.
0.4875.
Yeah, one answer is 48.75%, but I'm a little bit confused about the other half, sir. Because is there any relation between pilot striking and then driver striking? Because as per the expression given in the example, it is the other way around, I think.
I think sir is not there.
Point
in the
9.
meeting.
Second one is.
Sir is not there in the meeting, I think.
What was the question for part B? Neither of them striking.
Actually, sir, the relation is the other way around, whatever is asked in the question. You see, pilots were on a sympathetic strike actually, once drivers goes on strike, but here the other way around.
Why sir is there not in the meeting?
Sir got disconnected, I think.
Yeah.
That's the thing.
Exited.
I'm thinking we should use the Bayes theorem where he told one formula for dependent
Did anyone
probability of.
understand what was the question number part B of the question?
Ranjiti, can you hear me?
I can hear you.
Okay. Part B is probability of driver striking given pilot is striking.
Okay, thank you. Thank you.
So I'm thinking we have to use the Bayes theorem. We'll wait for sir.
We need to derive from that, yes. So we have probability of PS by DS. We need to find out DS by PS.
Correct.
What's the answer is? Is it 0.78?
I'm getting 0.9. Because
0.78.
Did you say 0.78 as answer?
Yeah. Yes. 0.78. Yeah, agree. I did it wrongly. Yeah.
I lost my connection. Now, am I connected? You can.
Yes, sir, we can hear you, but there is a break in your voice.
And screen?
The screen is not visible yet.
Okay.
No. Even your voice is also breaking in between. Not very clear.
Hello.
Yes, sir. It's clear.
The screen is not visible.
Okay, Kiran ma'am, it's showing host disabled participant screen sharing.
She has made you host.
Okay.
We can see your screen, sir, now.
Good. So this is what we were doing. What is the first answer?
So 0.585.
And the second one?
So 0.78.
So correct. Now you can, if is there anyone not able to solve? The first part is both strikes means probability of PS and DS. Because this is a case of conditional probability, therefore it will be probability of PS given that drivers are strike multiplied by probability of drivers striking. So that is 0.90 into 0.65. Am I right? 0.90 into 0.65. And the second one will be probability of DS given that pilots are on strike. And that will be probability of PS into DS means which you have calculated in the first part, 0.585 divided by probability of pilots striking, that is 0.75. It comes out to be 0.78.
Can you just
now we come to this application of Bayes theorem.
Can you just note it down? Can you just write it down? I think you're missing the.
Sorry.
Can you just note it down on the paper like it's shown for the others? I'm not able to follow the trail.
So okay, but have you written something? Have you made any attempt to solve?
Yes, I've done that.
Hello.
Yes.
So what is your answer? What is your answer?
Mine is coming 0.91 for the first part. Determine the probability of both troops striking.
Mine is coming to 48.75. It is not 0.75 into 0.65.
The first one?
Yes.
No, it's 0.90 into 0.65.
0.90 is not a probability of B1 bar B2. Probability of B2 is 0.65 or 0.9.
Now, what do you want to calculate in the first part?
First part is both groups striking.
Means and.
Yes, and. So I took probability of B1 as 0.75 and probability of B2 is 0.65.
देखिए, now look here. आपको ये निकालना है ना, ये वाला second one. Isn't it?
Your video is off, I think, Jonathan.
Video, but you can see this.
Yeah, sir. Actually, there is. So, should we need to take probability of B2 as 90% or 65%?
No. So, first is the expression. We are talking about the second one.
Yeah.
Here,
expression is multiplication probability of B1 into probability of B2.
Right. So, what is, say, for example, A is probability of driver striking, and B
A is probability of driver striking.
And
probability of B is probability of handler striking.
Pilot strike, right? Yeah. So accordingly, this expression will become probability of pilots striking given that drivers are on strike. How much is that? Yes, how much is that?
90%, 90 into 90% of point.
0.90.
Yeah.
Into what is point A? Point A is again probability of pilots striking. Sorry, drivers striking.
Yeah.
So drivers striking is 65%. So therefore it is 0.9 into 0.65. Done?
Noted. Yeah.
Huh?
Understood. Yeah.
Okay. And the second one is just rewriting or rearranging the terms. Now this is an application of Bayes theorem. So in this case, here the results are given, you can say, and you have to find out the cause. Say two suppliers S1 and S2 supply a machine part to a manufacturer of a machine tool. S1 supplies 70% of the requirements and the rest is supplied by supplier S2. Historically, 95% of S1 supplies are good and 5% are defective, whereas S2 supply is acceptable 90% of the time. Now, one day a machine breaks due to a defective part supplied by either of the two suppliers. Given the information that the part is defective, what is the probability that the part was supplied by S1? So here the event has occurred or result has occurred. You want to know the cause. Means there was a breakdown due to the component which was either supplied by S1 and S2 because there are only two suppliers. So a machine breaks owing to defective part. अब ये defective part was supplied by either of the two because there is no third supplier. So the situation is that the part is defective because machine has failed. So part is defective. What is the probability that the part was supplied by S1? Second part is by S2, just for practice. So you can note down the first expression and then we will discuss. Note down the first expression and try to understand. How will you read the left-hand side of the first expression?
Probability of supplier 1 is to be
Effective part is from supplier 1, right?
A bit more, you please elaborate more on this.
Given defect is occurred, the part is from S1.
Okay, anyone else?
probability that the defective part is supplied by S1.
Okay, or any other form to express the same thing?
In statistical terms, it can be explained that considering the defect has occurred, the defective part is supplied by S1.
Yeah. So this is what we want to know. This is what we want to know. What is the probability that the part was supplied by S1 when it was defective, or given that it is defective? Now the expression for this is in the numerator is probability of S1 multiplied by probability of defective when it was supplied by S1. So I repeat, the numerator is probability of that the part is supplied by S1 multiplied by probability that a defective part is supplied by S1 means probability that a part is defective given that it was supplied by S1. So this, you understand now? The numerator part is clear?
Sir, is it? Yes, sir.
Now, in denominator, we have all such probabilities. What probability? The first one, the numerator one, plus the second possibility, which will be exactly the same, but for the second supplier. You can compare the first and the second component. They are exactly the same thing written for the second supplier. And all these values are given. What is PS1?
70%, sir.
0.7.
Probability of supplier 1 supplying the product.
PS1 is
0.7.
7. And PDS1?
0.05.
No. Yes, that is 5%, correct. And what else is required?
PS2,
DS2.
0.3.
DS2 is
0.1.
0.1 and PS2 is 30. PS2 is how much? 30%.
PS2 is 0.3. Yes.
0.3. I'm not going into detail of this expression because of the time constraint, because we have to cover other topics as well. But here, just one thing I would like to tell, that there are there are concept of prior probabilities, conditional and posterior probabilities when we are talking about Bayes theorem. The first set of probabilities, that is probability of S1 and probability of S2. ये जो information है 70%, 30%, this set is called prior probabilities. ये known है हमको. दूसरा set of information जो है वो conditional probabilities कहलाएगा, जिसमें क्या हुआ PD/S1 और probability of D/S2. ये set of probability जो है conditional probabilities है. The third set of probabilities is the posterior probabilities, जो आपकी लेफ्ट हैंड साइड है यहाँ, चाहे probability of S1/D और probability of S2/D जो सेकेंड एक्सप्रेशन है, दोनों. तो ये posterior probabilities होती है. So the first set, which is known with certainty, is prior probabilities. I repeat, it is PS1 or PS2. ये दोनों, this set of probabilities, they are prior probabilities. Conditional probabilities, what are the conditional probabilities? Probability of defective when it was supplied by S1 and probability of defective when it was supplied by S2. ये set जो है 0.05 और 0.10 ये conditional probability है और S1D और S2D ये posterior probabilities है. This is some, I mean, this terminology which is used in the context of Bayes theorem. So
just for the understanding, is the number 53.84 for S1, probability for S1?
S1 is 70%.
No, the part A.
Answer, yes, 0.53, 0.54 you can say, 0.54.
5384, okay.
5384, yes, correct. 5384. So that is the means 53.84 or roughly 54% is the probability के जिस part की वजह से, जिस defective part की वजह से machine breakdown हुआ, 54% चांस इस बात के हैं कि वो part supplier S1 ने supply किया था. You should be able to interpret it also. This 0.5384
yes.
or 54.
And the other one is 46.
Yes, is the probability that the part which has been responsible for machine failure, a defective part which is responsible for breakdown of machine, was supplied by S1. Iski probability 54%. Or 46% is the probability that that part was supplied by
S2.
Other party.
Yes, supplier 2. यहाँ अगर 3 होते, थर्ड सप्लायर भी होता, तो अकॉर्डिंगली डिनोमिनेटर में आपके एक थर्ड सप्लायर के लिए भी सिमिलर एक्सप्रेशन ऐड हो जाता, मींस प्लस PS3 डॉट PD/S3. That's all.
Got it. Thank you.
Okay. Any question till now? Because now I will be switching over to probability distributions. Or we can this probability distribution we can take up tomorrow then. Any question till now?
So just answer for the second question, sir.
Which second question?
For 46.15%.
Okay.
Second part means
second part, sorry, yeah, second.
It is supplied by S2.
Yes.
So it is simply 46% because there were two suppliers. So 54% is the answer for the first one. Okay. Now I will request Kiran ma'am to share a numerical sheet. I prepared a numerical sheet where we have numericals on these numericals which we have done here and some more numericals on these topics. So you can exercise, you can practice from that sheet as well as from your textbook. Because as we know that for any topic there are a number of problems available in your book, and there can be any number of problems on any particular topic. So we can't cover all of them here. So what I've tried is to take up different type of problems, at least one of one type, and we were solving here, giving you the time to solve and then discuss, but very few have asked anything. It's up to you, but I mean, I have given time for each problem for you to solve, and wherever it was possible, I've shown you on paper or slide a solution, at least some steps I have shown. So on that basis now, you should practice few more examples from the sheet that I will be sharing with you through Kiran ma'am and also from the book. So here we stop for this topic.
Thank you, sir.
We'll take a probability distribution, and I will suggest for tomorrow that you should have a hard copy of statistical tables with you. You can note it down from somewhere. You just arrange Poisson distribution, binomial distribution and normal distribution. इन तीनों किसी भी स्टैटिस्टिक्स की बुक के पीछे आपको ये मिल जाएंगी. नॉर्मल डिस्ट्रीब्यूशन की टेबल, पॉइजन डिस्ट्रीब्यूशन की टेबल्स और बाइनोमियल डिस्ट्रीब्यूशन की टेबल. तो इन टेबल का यूज होगा और एज यू नो इट्स मींस it will be difficult for me to show the table, to show the slide, solve it. So something you should have in hard
Yes,
form with you, so that I can show here, but it will be easy if you also have a copy of those tables with you.
Okay,
our
sir.
books have it in the back, sir.
Okay. So we stop here, and good night.
Sir, the
Thank you,
slide,
sir.
Meeting.
Thank you, sir.
Yes. Any question?
no, the slide can be sent today. Like,
Everything will be sent. Everything will be sent. No problem.
Yeah.
But the only thing required is that we should practice as much as we can during the class and after the class. Okay. So tomorrow we are meeting at 7 again.
Sure.
Thank you, sir. Good night, sir.
Thank you, sir.
Have a good night.
Thank you, sir.
Bye all.
Thank you, sir.
Thank you.
Recording stopped.